Hello everybody and welcome back to another brainstorm. Today we're going to be talking about moles and molar calculations. Now this is part 1 in the quantitative chemistry series. This is for GCSE chemistry, so be sure to check the rest of that out. And we're going to split this video up into 3 main parts. First of all, we're going to talk about what is a relative atomic mass and lead that onto the idea of moles. Then we're going to talk about the relationship between moles and mass in grams. And we're going to finish off by doing some molar calculations with balanced symbol equations. So let's get into it. Alright guys, so before we talk about moles or any sort of calculations, we need to grasp this idea of a relative atomic mass or a relative formula mass. So our relative atomic mass is the mass of an element relative to carbon. So this is a bit different to the usual mass that we think about. So I could say, oh, I've got 2 grams of oxygen, but that isn't relative to anything. That's a given amount. Our relative atomic mass has no units like grams or kg, it's all relative to carbon. So for carbon, it's the mass of an atom's protons plus neutrons. So our relative atomic mass for carbon is 12, and that's because it's got 6 protons plus 6 neutrons, okay? And when we're talking about the periodic table, so this is usually where we find all of our relative atomic masses. Let's just take oxygen here, for example. Our relative atomic mass is going to be the larger number. This is called the mass number. So for oxygen, although it says here 15.99, for the sake of our calculations, we say it's 16. In addition to this, the relative atomic mass is the mean average mass of all isotopes of an element. So you'll remember we said that isotopes are 2 atoms of the same element that have a different mass number, i.e. they have a different number of neutrons in their nucleus. So although these guys have the same chemical properties, they can have different physical properties, and one of these is the atomic mass. So for example, if an element had an isotope with a mass of 36, had another isotope of mass 37, the relative atomic mass we use for that would be somewhere in the middle, so we'd go 36.5. That's the mean average. And so the relative formula mass is quite similar as well, but it's the mass of all of the atoms added together in a compound. So for a question, you might be asked to find the relative formula mass of a compound, so let's look at how we do that. So here we have an example. This is ethanoic acid, and we want to find the relative formula mass of it. So what we need to do is we need to split this into its individual atoms. So we'll start with carbon. We see that it has 2 carbons, so we'll put 2 carbon. And now we'll go on to hydrogen. It's got 4 hydrogen, H3 plus 1 mole, so we'll put 4 hydrogen. And we've got 2 oxygen here as well, so 2 oxygen. Then we need to find the individual atomic masses for all of these. So we said here that the relative atomic mass for carbon is 12, but we've got 2 carbons here, so it's going to be 12 times 2, 24. Hydrogen has an atomic mass of 1, we can find that on the periodic table, but we need to have 4 hydrogen, so our atomic mass for that is going to be 4. And then oxygen, like we can see here, has an atomic mass of 16, but we've got 2 oxygen here, so it's going to add up to 32. Then to find our formula mass of ethanoic acid, we need to add all of these together, and that equals 60. One final thing that we need to note is that throughout chemistry, and especially this video, our atomic mass is often represented as AR, the letters AR. It just saves us having to write out relative atomic mass each time, and our formula mass is written out as MR. So down here we could say that the MR of ethanoic acid is equal to 60. And remember, we don't need units because it's all relative to carbon. Alright, so now we know what a relative atomic mass is, now we can discuss what exactly is a mole and what's the relationship between the mole, the relative atomic or formula mass, and the mass in grams, okay? So a mole is essentially just the relative atomic or formula mass of a substance in grams. So you remember that for ethanoic acid, we worked out that its relative formula mass was 60. So what we mean by this is that if I had 1 mole of ethanoic acid, it would weigh 60 grams. And from this concept we developed this very important formula triangle, which is that moles is equal to mass over mR, mass is equal to moles times by mR, and mR is equal to mass divided by moles. Another important thing that we need to note is that 1 mole of any substance contains 6.02 times 10 to the 23 particles. This is a very large number, which is known as Avogadro's constant. And essentially what this means is that if I had 1 mole of ethanoic acid, it would contain 6.02 times 10 to the 23 particles of ethanoic acid in it. Okay, so now we've grasped the concept of what a mole is and what our relative atomic / formula mass is, we can put this into practice with 2 exam style questions that we're going to work through together. and I've written down our relationship between the three over here. Okay, so our first question is, how many moles of sulfuric acid is there in 4.9 grams of sulfuric acid? So straight away we'll see that it's asking us for moles here. And we see that from our formula triangle that moles is equal to our mass divided by our MR. So first of all, it's really simple to find the mass. It's given in the question, and it's 4.9 grams. And in chemistry, all of our masses are in grams, and that already is, so we're fine. MR next. So first of all, we need to find out what is the formula of sulfuric acid, and for us that is going to be H2SO4. So once again, to find the formula mass, we need to split this into its various atoms, and I've written the individual atomic masses here. These can easily be found on the periodic table, you'll remember. So first of all, we've got 2 hydrogen. We see here that the hydrogen has a mass of 1, so 2 is going to be 2. We have 1 sulfur, which is 32, and we're going to add to that 4 oxygen. So 1 oxygen is 16, times that by 4, we've got 64. And remember, in the GCSE exam, you do have a calculator, so you can use a calculator to add these all together. But altogether, that comes out to be 98. So we're going to take this formula here, and we're going to take our mass, which is 4.9. We're going to divide that by 98, and that comes out to be 0.2 moles. And remember, we're only going to give it to 1 dp, because in our question, all the figures are in 1 dp as well. So, the second example that we have is that what is the mass of 7.5 times 10 to the minus 3 moles of aluminium sulfate? So this time we're not asking for moles, we're asking for mass here. So we'll look at the formula triangle over here, and it says that mass is equal to moles times by our MR. We're given moles already in the question, so we can write that straight down. Moles is 7.5 times 10 to the minus 3. Very small number, but that's not uncommon. So now we're going to find our MR. First of all, we need to do the formula of aluminium sulfate. So that is Al2SO4 Now that looks like a bit of a complicated formula, but once again, we're just going to break it up into its components. So first of all, we have Al2. 1 Al is 27, and if we want 2 of those, that's going to come out to be 54. And now we've got this little bracket situation with the sulfate ion. So what we do is we find out what is the mass inside of the bracket and times it by the 3 here. So for S, we've got 32. To that, we're going to add 4 oxygen, which remember we found to be 64. And that comes out to be 96, but we need to times that by 3. So altogether, that is 96 times 3, which is 288. And add that 54 to it. That comes out to be 342. Okay, so now we're going to take our formula here. We're going to do 342, and we're going to times that by 7.5 times 10 to the minus 3. So I'm just going to type that into a calculator here because it's pretty difficult numbers to work in your head with. And overall, that comes out to be 2.565. And I'm asking for grams, so that's going to be in grams because it's mass. But the question here only gives its figures to 1 dp, so we're going to round it that much too. So it's going to be 2.6 grams. Okay, so those were some pretty simple molar calculations, just putting a couple of ideas together. So we're going to continue looking at molar calculations. These ones are a little bit more difficult, but we'll get through them. So the first thing that we need to know, and the most important principle in this, is that the multiplier in a balanced equation tells us the ratio of moles that react together. So what is the multiplier? So you'll see an example of a reaction here. This is a reaction between hydrogen and chlorine to produce hydrochloric acid. And with our hydrochloric acid, you'll see that it's big 2 HCl. So our multiplier here is 2. Now don't confuse this with the little 2 next to hydrogen or the little 2 next to chlorine, okay? These have nothing to do with it. It's the big number in front of it, which is a multiplier. So up until now, in a balanced equation, all the multiplier has told us is how many molecules are reacting together. So for this one, we have 1 mole of hydrogen molecules, and that reacts with 1 chlorine molecule, and this produces 2 molecules of hydrochloric acid like this, okay? But now we know what a mole is, and essentially all this big number is a ratio between the different moles that react together. So for every 1 mole of hydrogen that reacts, it has to react with at least 1 mole of chlorine, and this will produce 2 moles of hydrochloric acid, okay? And remember that this is a ratio, so it can be scaled up and down. So now it says 1 plus 1 is 2. This could be 10 moles, reacts with 10 moles to form 20 moles. Could be 8 moles and 8 moles form 16, etc, etc. It's just a ratio. Go. Okay, so up until now we talked about some pretty simple molar calculations, just stringing these 3 ideas together, but now we're going to talk about a typical exam style molar calculation, which we're going to work to together. So here's the example here. Sodium hydroxide reacts with chlorine gas to make bleach, a description of how the reaction occurs, and they've given us the balanced symbol equation, which is very useful. Now the question asks, if you have a solution containing 100 grams of sodium hydroxide, what mass of chlorine gas do you need to convert it into bleach? So right off the bat, this looks like a pretty complex question, but we're just going to use our simple ideas which we learnt about here and work through the question together. So in the question, it's only talking about sodium hydroxide and chlorine gas, so i.e. it's only talking about the reactants. So my top tip is to write these out a little bit bigger. So it's 2 sodium hydroxide and that reacts with chlorine gas. So first thing we need to notice is that we have multipliers here. Now we have 2 sodium hydroxide, so that's our multiplier there, and there's no number in front of the chlorine. So in balanced equations, when there's no number, we assume it's 1. So you'll remember from the ratios that we were talking about, all this means is that every 2 moles of sodium hydroxide reacts with 1 mole of chlorine in a 2-to-1 ratio. And because for this ratio we're talking in moles, everything we do here is going to start off by us converting into moles. So we'll start with sodium hydroxide. We have 2NaOH. So we've been given the mass first of all, and that's in the question. It says it's 100 grams of sodium hydroxide. We need to find the MR before we can convert into moles. So for the MR of sodium hydroxide, we're definitely not going to count the multiplier into this. So first we find sodium. Sodium has an atomic mass of 23. We're going to add it to oxygen, which is 16, and hydrogen, which is 1. Altogether, that comes out to be a formula mass of 40. And you remember from our triangle right here that moles is mass over MR. So we've got a mass of 100 divided by 40, and that comes out to be 2.5 moles. Okay, so now we're ready to use our ratio here. We said that every mole of sodium hydroxide reacts with half as many moles of chlorine, okay? So to find the moles of chlorine, now we're talking about Cl2 here, we just have to halve our number, and halve 2.5 is equal to 1.25. So we have 1.25 moles of chlorine in this reaction, and we've been asked to find the mass of chlorine. So to find the mass is moles times by MR, so let's find the MR of chlorine. So just 1 chlorine on its own is 35.5. We have 2 chlorine, times that by 2, and so that comes out to be 71. So if we want to find our mass, what we need to do is we need to do 71 our MR times by our moles, 1.25, and that comes out to be 88.75, and we're talking about mass, so that goes in grams. Now, in our question, all of our figures have been given to 4 significant figures, so we'll leave our answer as this, and the answer is 88.75 grams. And with that, I'd just like to say thank you guys all for watching. Do make sure to check out the rest of the Quantitative Chemistry series, and please make sure you hit like and subscribe if you want to see more videos like this, and I'll see you guys soon.